안녕하세요, 웍스클래스입니다. 무선통신 기술이 중심이 된 지금 안테나 엔지니어분들의 가장 큰 고민은 무엇일까요? 맞습니다. 바로 눈에 보이지 않는 전파를 제어하는 것이죠. 안테나는 아무것도 없는 공간에선 잘 작동하다가 도주변의 고무나 플라스틱 혹은 사람의 몸만 닿아도 주파수가 틀어져 버립니다. 이 치명적인 주파수 천이 현상 때문에 수많은 엔지니어들이 밤새도록 시제품을 만들고 깎고 테스트하는 무한반복의 늪에 빠지곤 합니다. 정지해 있는 전자제품도 주변 물질만 바뀌어도 주파수가 쉽게 틀어집니다. 그런데 축구공처럼 내부 공간은 극도로 작고 경기 중에는 선수의 강한 슈팅으로 계속 형태가 찌그러지는 환경이라면 어떨까요? 초당 수십 바퀴씩 회전하는 물건 안에 완벽한 안테나 시스템을 구축해야 한다면 어떨까요? 전파 방해와 주파수 천이가 실시간으로 몰아치는 그야말로 엔지니어에게는 악몽과도 같은 극한의 상황일 것입니다. 이 말도 안 되는 불가능을 완벽한 현실로 만들어낸 엔지니어들이 있습니다. 바로 전 세계가 열광하는 프로축구 무대그 경기장 한복판에서 말이죠. 오프사이드와 골라인 판정을 밀리미터 단위로 정확하게 잡아내는 축구공 속 센서, 가죽과 고무 속에서 6GHz의 신호가 어떻게 살아남았는지 그 경이로운 시뮬레이션 세계를 지금 바로 확인해 보시죠.
Picture this. It's minute 89. Your team is up by 1. The striker barrels down towards the goal. He shoots, bam! The ball smashes off the crossbar and rockets straight down. Did it cross the line? Half of the stadium erupts in celebration. The other half is screaming, no goal. The referee hesitates. Tensions spike. Chaos is seconds away. For decades, moments like this were decided by human eyesight alone. And over the last 12 years, technology has changed that. Modern match balls used in professional sporting tournaments contain an embedded sensor system that transmits the ball's exact position up to 500 times per second. Combined with stadium tracking systems, officials can determine instantly whether the ball fully crossed the goal line. Critical offside decisions, shot speed and movement data, and even the precise point where the player's foot makes contact with the ball itself. But that raises fascinating engineering challenges. How do you design an antenna system that works reliably inside of a spinning, deforming sphere? How do synthetic panels, adhesives, and internal bladder geometry affect signal transmission? How do you maintain millimeter accuracy in a stadium packed with 60,000 people and a forest of electronic interference? That split second between chaos and certainty is now solved not by debate, but by design. With Electromagnetics Engineer, part of SOLIDWORKS Simulation Suite, we can answer all of those questions. I'm going to look at two things: how the ball's material changes the signal of the antenna, and how we can track the ball as it is kicked and moved around the stadium. The antenna inside a tournament soccer ball doesn't operate in free space. It's surrounded by the ball's own materials, the rubber bladder and outer panels. It's designed to operate at 6 GHz, but those materials shift its performance. And as an engineer, I need to understand exactly how. For this, I'll use Electromagnetics Engineer on the 3D Experience platform. I start by simulating the antenna in isolation, then place it inside the ball to see how the structure shifts the resonant frequency off target, changes the radiation pattern, and reduces efficiency. I can visualize the electromagnetic fields to understand how the antenna is interacting with every layer of the ball. Once I understand the shift, I tune the antenna back to the target 6 GHz and confirm it's performing correctly inside real operating environments. Then I scale it up. I can place the ball anywhere, like right on the goal line, to see exactly how the signal travels, reflects, and reaches each receiver. I simulate how that signal propagates through an entire stadium. The ball is tracked by over a dozen antennas around the field perimeter, using time and distance of arrival to calculate its position. Coverage gaps, placement trade-offs, and edge cases are all evaluated before anything is physically built. This is how ball tracking and goal line technology are designed. Not by trial and error, but through electromagnetic simulation. All virtual prototyping is important. That importance is elevated when you're testing electromagnetic fields like wireless signals. Because what you're testing is invisible. It's easy to drop something and see where it breaks. But it's hard to figure out where electromagnetic waves will get stopped because you can't actually see them. As technology advances and evolves at a rapid, almost relentless pace, we engineers need to keep up. We need to be sure the products we built and invested in will work in real life. With the simulation technologies provided by SOLIDWORKS, we can know if an object from a massive stadium to a size 5 football will do what we need it to do, all with virtual prototyping and simulation. So no matter what big or small idea you're dreaming up, you can rest assured that with the power of simulation, you'll be unstoppable.
솔리드웍스를 배우고 싶다면 웍스클래스입니다.